This meeting is being recorded.
For problem 14 in chapter 21, we're asked to predict the major product obtained when each of these aldehydes are treated with sodium hydroxide. So we see that we're going to treat here with a strong base. So what happens initially is that we see here two molecules that are very similar. One of these down here below is the deprotonated, or rather the enolate form, we should say, of this aldehyde, this starting material here. So once we form the enolate after we react this aldehyde with a strong base, that enolate will react with the original molecule to form, in this case, we're going to see a beta hydroxyaldehyde. So let's see here how this would happen. Remember, we had enolate here, so one of these lone pairs can move down. Then this pi bond here acts as a nucleophile, attacks right there. And then what we see is further movement of the electrons up here. So we would generate, after this reaction, remember it's aqueous, so we have a proton source to protonate up here. This product below, and again, if this is the alpha site, this would be that beta hydroxy aldehyde product. Let's take a look at B here. We're going to see this similar thing happen here. So we have our starting material, we have down below, after it has reacted with aqueous sodium hydroxide, the enolate is formed. So we're going to do the same thing. We're going to move around some electrons here. We're going to have this pi bond act as a nucleophile. It's going to cause these electrons to move up there. Then after our aqueous workup, we can protonate this site here. And then in reaction B here, we're going to form this again. It's going to be a beta hydroxy aldehyde product. And this is that beta site there. Let's take a look at part C here. Hopefully we're sensing a similar pattern. Oh, there should be a proton there. That's an aldehyde. So in part C, we formed the enolate here. So we're going to move down there. We're going to have our pi bond act as a nucleophile, attack right here. That causes these electrons in the carbonyl to move up onto the oxygen. Then we see the formation down here of, once again, we have another beta hydroxyaldehyde that's formed. This is our beta site. And last but not least, this may be the hardest to see, but we're going to follow the same steps here. We're going to form our enolate by treatment with aqueous sodium hydroxide of this aldehyde in part D. Then we'll have movement of these electrons, the nucleophilic attack from our pi bond, shift of those electrons in the carbonyl up to the oxygen. Then we have our protonation due to water. But what we should note here, and we're missing this methyl group here. So that correlates with this group right here. What happened was this ethyl portion kind of flips down here, and then we have this other methyl group here. But once again, we're going to end up with this beta hydroxy aldehyde as our product.